All right, welcome back from the break. I hope you enjoy that little break. We are still on simplification of terms and expressions involving logarithm, and our interest is on case 2 when we have many log operators. And then we have actually looked at the first example. So we need to take more examples on this. Let's take more questions on this, following the steps that we have already. So if we take the next question here, let's claim there. Okay, let's do that. Question number 2, we have log 108 base 3 minus log 4 in base 3. Okay, another beautiful example. So we need to take that and see how far we can go on this. So as usual, take note of the expressions and check if the bases are the same. So we take note of this expression, log 108 in base 3 minus log 4 in base 3. Check if the bases are the same. Beautiful, the bases are the same, so we know where to begin and where to stop. In the previous example, we did not touch any of these because the bases are what? The same. This concerns a case when the bases are no longer what? The same. That's why we didn't touch those steps. All right, the bases are the same. They said, if the bases are the same, then we do the following. Use appropriate law or laws to reduce the expression to a single log what? 10. Use appropriate law or laws. Now we have looked at the laws that we can use to reduce multiple log operators to a single log. We say the first and the second law of logarithm. And here we have subtraction. So the law we are likely going to apply will be this. So we're going to have log m divided by n. The bases are the same, the bases are the same. The operation here is subtraction, the operation here is subtraction. So we say, when the bases are the same and the operation between the logarithms is what? Subtraction operation. We use the second number to divide the what? To divide the first. We use the second to divide the first under their common log. That's what I'm going to do here. Remember, there are two laws that can reduce multiple log to single log, the first and the second law. The first law will not work here because of their subtraction operation. If we have addition, that's when we apply it. So if we apply this law here now, we're going to reduce the whole of this according to the instruction given to us. Use the appropriate law or laws to reduce the expression to a single log 10. We're going to reduce this to a single log 10 by saying 108 divided by 4 in base what? 3. Okay, let me take care of this here. And when 108 is divided by 4, 4 divided is within 27, all in base 3. Then we have reduced it to a single log. What else should we do? Apply the method we use in simplifying single log to complete this operation. So we are going to have log. Which method is that? Ancestors method. You can still use your indicia method. If we are using indicia method, it means we just say 27 now. We equate it to a letter. You remember that. Take this to this side and we have 27 plus 3 raised to 4x. Then express both sides in the same base. In index form using the same base. This is 3 raised to 4 3 plus 3 raised to 4x. Equate the power, so 3 is equal to x. We now get our answer. If we are using indicia method, that's if we want to use indicia method, we now get 3. But we want to use ancestors method so that we don't need to equate to any other thing. We just solve directly here. So what do? We are going to write this and this in index form using their common ancestor. Fortunately for us, 3 is the ancestor of 27 and 3 is ancestor of 7. So if I write 27 in index form using 3, you have 3 raised to 4 3. This one is already 3, is the ancestor of 7. Then if we apply the third law, the power is here. I repeat again, for emphasis sake, when we have log, the third law, when the power is on the number, the same thing as the number multiplying the log. Somebody will say, you keep repeating this. Yes, I need to make sure that it is part of you. That's why we are here. We're not just here to impress you, to solve problems. No, we want you to learn. That's why we lay emphasis where necessary. So this is in this form, but we don't want it in this form. If you leave it like this, we cannot solve, we can't do any other thing. So we must look for a way to translate this or transform it. And then that's what the third law does. You look at this third law. When the power is on this, we can write that same power as the coefficient of the log. So this is an alternative form of writing this. And if we apply it here, we're going to have 3 log 3 now in base 3. This 3 now is the coefficient of the log. Now applying the fourth law once again, logarithm of a number to its own base is what? 1. So we are left with 3 times 1. That will give us what? 3. So the whole of this now is equal to what? Is equal to 3. It's equal to 3. It's equal to 3. Alright. We're going to take one more example before we go on another break, so that when we return, we will conclude this particular part and look at the next case as far as simplification of terms and expressions involving logarithm is concerned. Okay, let's take one more example. Remember, if you are confused at any stage, you pause the video, start afresh. You know, when you are trying to cram a particular music, or when you are watching movie and you look at it, there is something that happened in that movie that you did not really understand. You want to hear what one of the actors or actresses have said. You rewind. You just have to rewind and rewind and rewind until you don't say, okay, is that what this man said here? So the same way, if there is anything you did not really understand, you need to rewind the video, rewind it again until you have really had an understanding of that particular area. It's very, very important. Very important. So let's take question number 3. Let's take the third question. Question number 3. Let's see if we can have a case where we have 3 log operators. Oh, beautiful. I think I have that. I have 3 log or 2 base 10 plus log of 20 base 10 minus log 1.6 in base 10. Beautiful. So in this case now we have just 3 log operators. The other one we will have just 2. Now we have 3. Okay, the same method. They say take note of the expressions and check if the bases are the same. We have checked that base 10, base 10, base 10, they are the same. So that log 20 base 10 minus log 1.6 in base 10. Oh, we have a little thing. Let me create a space so that we'll not have this. So 3 log 2 base 10 plus log 20 base 10 minus log 1.6 in base 10. Okay, I think this is enough for us to write the next expression. So we have it. Now they said when the bases are the same, we do the following: use appropriate law or laws to reduce the expression to a single log term. We have a problem. What's the problem? These 3 will not permit us to reduce this to a single log until we deal with it. If we go back to the third law, you see, that's why mathematics is very sweet. Sometimes you need to think outside the box. Already that these have told us, use appropriate laws and to reduce this to a single log. Somebody will say, okay, these 2 are adding, we'll multiply 2 times this will give me 40. What of these 3 here? What of these 3? We need to deal with it. It's a stumbling block. It's one thing that will not permit us to go further. If we fail to deal with this, we cannot go further. In a journey, there are things that if you fail to deal with, you cannot go further. So we are on a journey here. We cannot go further. We cannot apply this particular step unless we first of all deal with the issue of this 3. And somebody is thinking, how am I going to deal with this? Invoke your laws. invoke your laws. As long as we have this, we cannot reduce this. Let's look at the laws. Remember the laws that we use in reducing a term, an expression to single log term. We have this. Okay, we have this as log m times n, so that you think we have this log m dark minus log m dark, we have log m all upon n. Okay, let's think about it. This is the form in which this appears. Okay, none of them has a coefficient here. You see, the coefficient is just 1. See? So it's not possible to actually use this here now when we have 3 here. So we must deal with these 3. These 3 must go so that we don't have any number like we have here until before you can now combine it. So this 3 is a stumbling block. So how do we deal with it? Oh, beautiful. We have a way of dealing with it. Don't cry. Don't shout. If you shout, it will be a problem. If you cry, it will be more problem. So let's not shout, because there is a way. There is a way. Even people that are in prison can break the prison anyway, but we are not here in prison, and we have a way out. You understand that? We have a way out. We are not in any prison here. Some people say, no, I'm in trouble. It's not yet a problem. Let's see what the law, one of the laws says. If we go back to the third law, we say that log m raised to power base a is something as p log m in base a. Beautiful. Now this is in this form. So another way we can write it is to push it like this. In other words, to bring this 3 as the power of 2. And you know, if we do that, this number will no longer be there. So we have something like this. Then we can reduce to a single log. You see that? So knowing what to do at any point in time matters so much. And that's why these laws are there. We treated these laws so that when you have a problem, you will know the appropriate law or laws to apply in order to solve your problem. Failure to do that means that someone will be in trouble. But thank God for the laws. The laws have delivered us from trouble. So if we apply this here on this, we are going to write this as what? Log 2 raised to power 3 base 10 plus log 20 base 10 minus log 1.6 in base 10. That's what we are going to have. Beautiful. So we go again. 2 raised to power 3 we know is what? 8. I have log 8 base 10 plus log 20 in base 10 minus log 1.6 in base 10. Okay? Now these two are adding, then this one subtraction. Let me first, I can do all of them at the same time, but let me break it down. We say when 2 logs are adding, what do? We multiply them under their common log. So I can write this as log base 10, 8 times what? 20 minus log 1.6 base 10. Why do I have to multiply this? The 2 logarithms, they are of the same base, and the operation between them is what? Addition. So if I break that down, I'm going to have 8 times this will give me what? 160 base 10 minus log 1.6 base 10. Okay. I apply the first law here. You know that when we have log m plus log n all in base a, we say m times n, log m times n in base a. So we move on. Now we have subtraction. The bases are the same. What do? We use the second number to divide the first number. This law, we are now singing it like a song. I believe that it is now part of it. So 160 over 1.6. Then we have 160 over 1.2 is in base 10. We give me log 100 in base 10. Oh, beautiful. Log 100 in base 10. And we may decide also to finish it up somewhere here. We may decide to finish it up somewhere here. Remember that when we have, I don't want to clean the steps because it will be helpful. Well, very, very helpful. We need to be making reference to the steps. So remember, Having reduced this to a single log, that's what we have been doing. Use appropriate log to reduce it. So we are just applying all the logs to bring it to this single log. They now say, use the method for simplifying single log. So I will have ancestors method. I can write 100 in terms of this ancestor 10 like this. Then I will go further to translate it using the third law. We have mentioned this third law so much. So we write 2 log what? 10 base 10, and then log 10 in base 10 is 1. When you do that, you have 2. So you see, the whole of this is just 2. That's what we mean by simplify. See how big it is. We just reduce it to 2. You know, there's no mathematics they call simplify. Simplification is just is just English word, which means reduce this to the smallest possible form. That's what it means. What we mean by simplify. When you're asked to simplify, it means to reduce that expression to the smallest possible form. You look at it, it's just simpler when you compare it to this. Okay, beautiful enough. I believe the meal is sweet. We're going to go on a short break again to allow this one to digest. When we return, we're going to solve more problems. Still on case 2, where we have many log operators. But this time around, we may be looking at expressions that have different bases. Keep watching Mathematics Mail. Remember, a meal a day from Mathematics Mail will make you healthy in mathematics. Thank you and remain blessed.